Okay, welcome back. This is Mr. Hassan's Maths channel, and this is question number 10 from the Solomon D collection of the C1 papers, which corresponds to the new P1 Edexcel International A-Level. This is question number 4 for my end of topic worksheet, number 5, called Straight Line Graphs, for my P1 collection at school. And this is a question that a student has asked me. He asked me actually part D, but just for completeness sake, I will answer the whole question. So part A says the straight line L1 has equation 2x plus y minus 14 equals 0 and crosses the x-axis at the point A. Find the coordinates of A. Well, it crosses the x-axis when y equals 0. The equation of the x-axis is y equals 0. So when you substitute y equals 0 into the equation, you will get the point where it crosses the x-axis. So if you substitute instead of y 0, so 2x plus 0 minus 14 equals 0, so you end up with 2x equals 14, so x equals 7. So the coordinates of the point A, 7 and 0. Okay, simple as that. So that's part A done. Now going on to part B. Okay, so part B tells us that the straight line L2 is parallel to L1 and passes through the point B minus 6, 6. Find an equation for L2 in the form y equals mx plus c. So to find the equation of a straight line, you need two things. You need to have the gradient of the line, and we need to have any point on the line. Okay, so we know there's a point which they told us is B, which is minus 6, 6. What we have to do is find the gradient. Now, they told us line 1 is parallel, line 2 is parallel to line 1. So if we look at line 1, we take the equation of line 1. The equation of line 1 is 2x plus y minus 14 equals 0. So if you rearrange it to make y the subject, you'll end up with y equals minus 2x plus 14. So we can say the gradient of line 1 is equal to minus 2, don't write just the coefficient of x. Therefore, the gradient of line 2 is parallel, so it's also equal to the same gradient. So the gradient of line 2 is minus 2, and it goes to the point minus 6, 6. So we can find the equation of the line quite easily by using y minus y1 equals x times x minus x1. So we can say y minus y1, which is 6, equals m, which is minus 2, times x minus x1. So it's x minus 6, which is x plus 6. Now, they want in the form y equals mx plus c, so I'm going to make y the subject. So I have y minus 6 equals minus 2x minus 12. And then, so therefore, y is equal to minus 2x. And you got minus 6 plus, minus 12, plus 6, which is minus 6. So y equals minus 2x minus 6 is the equation of the line which is parallel to line 1 and passes through the point B, minus 6, 6. Now for part C, it says the line 2 crosses the x-axis at the point C. Find the coordinates of C. So we know that line 2, its equation, as we just found, is y equals minus 2x minus 6. So it crosses the x-axis of the point C. So the x-axis is when y equals 0. So therefore, you're going to have 0 equals minus 2x minus 6. So you end up with 2x equals negative 6. So x is equal to negative 3. Okay, so the coordinates of the point C are minus 3 and 0. Okay, so that's part C done. Now, the question that was asked was actually part D. And part D says the point D lies on line 1 and is such that CD is perpendicular to line 1. Okay, so let's just show that coordinates have the point. D has the coordinates 5, 4. Okay, and what is this thing over here? That thing's not supposed to be here. That's from a different question. Ignore that for now. That's from a different question underneath it. So the point D lies on line 1 and is such that CD is perpendicular to line 1. Show that D has coordinates 5, 4. So let's just bring back what we have here. I'll just bring all the information across. Okay, now if we make a little sketch to try and picture what's happening here, just make a little sketch, and that might help us picture what's going on. It's always a good idea to do that when you have these graph questions if you've got time. We know that the line 2 is going through -6 and it has a gradient of -2. So it's going to, you can see from this equation that it's going to pass through the x-axis at -3, as we worked out already. Okay, and it's going to pass through the y-axis at -6. So it's going to have a gradient like this. And line 1 is going to pass through the x-axis at 14, and it's going to pass through the y-axis at 7. So it's going to, I'll just try and make this a bit more realistic, put it a bit more to scale. Okay, so let's just say that the parallel lines that have the same direction, this is 7, 0, this is -3, 0, this is -6, and this is +14. Okay, so they're asking us that the point D lies on line 1 and such that CD, okay, so this is the point C. If we remember, point B was where, A is where the first line 1, crosses the x-axis. So remember, this is line 1, this is line 1, and this is line 2, and this is the point D, and that's the point C. This is 7, 0, this is -3, 0. Okay. Okay. So that's point C. Well, sorry, that's point A, not C. So like that. That's the point A. That's the point A. And that's the point C. That's the point A. The point C is -3, 0. Okay. B is, we needed that for that. C is where L2 crosses the x-axis, which is -3, 0. Right. That's what we got. Okay. So now it tells us that D lies on line 1 and it's such that CD is perpendicular to line 1. So basically there's another line which is like this. Okay. So the line CD is perpendicular to line 1. Okay. We've got to show the coordinates of the point DR is 5, 4. Okay. So basically what we need to do is to find the equation of this. Let me call it line 3. If we find the equation of line 3 and solve simultaneously with line 1, we will find the coordinates of D where they intersect. So our objective now is to find the coordinate or find the equation of line 3. So line 3 is our objective. Now for line 3, we know the gradient is the negative reciprocal of -2, which is a half. The gradient is equal to a half because this line is perpendicular to line 1, as they told us. Therefore, its gradient is a negative reciprocal. So you take the gradient of line 1 and 2, which is -2, and you turn it upside down and change its sign. And we know that it goes through the point C, which is -3, 0. So we can find easily the equation of the line L3. So you have y minus y1, which is 0, equals a half times x minus x1, which is x minus -2, which is x plus 3. So we end up with 2y equals x plus 3. Okay, so that's the equation of line 3. Now I need to solve this simultaneously with the equation for line 1 because I want to find what line 3 hits line 1, and that will be the coordinates, that will tell us the coordinates of D. Okay, so let me just make a bit of space here. So I need to solve simultaneously the equations, line 1. So you got 2x plus y minus 14 equals 0. 2x plus y minus 14 equals 0. And also the equation for line 3, which is basically x, if we bring everything together, minus 2y plus 3 equals 0. So if I solve these simultaneously, I have to either use substitution or use elimination. I think I'll use elimination. So for example, I can make the y's the same by multiplying the top equation by 2. So I have 4x plus 2y minus 28 equals 0. So when I add these two equations together, I'll have 5x is equal to, and if I add these, the y's will disappear, and 5x and that's going to be equal 0. And I have 3 plus minus 28, which is minus 25. So I'll say 5x equals 25. So x equals 5. And I think that's what we had to show. Good, the x coordinate is 5. So far, so good. And we can find the y coordinate by substituting into any one of these equations for line 1 or line 3. So let's put it into this equation. So we got 2 times y equals, instead of x, I'm going to put 5. 5 plus 3. So 2y equals 8. So y is equal to 4. So we prove that the point D is equal to, okay, 5, 4. Okay, that's the point where they intersect. So we found the equation of the line 3, and we found we solved it simultaneously with the line 1, okay, which was given to us in the question. So that was how we did part D. And then it says part E, find the area of the triangle ACD. So this is where having a diagram really helps. Now we can see that this is a right angle triangle. Okay, and this is the base, and you can say this is the height. I could use these two lengths. Okay, but the problem is I don't know the length of DC and AD. I can find it because I know the coordinates, but I'm going to have to use like the length formula, which is complicated. What I notice here is I notice that the y coordinate of D is 4, and the x coordinate of D is 5. Well, we don't need the x coordinate of D, but that means this is 0, 4, and this is, so I know that the triangle, if it has this shape over here, which it does, with the x-axis, that this is the vertical height of the triangle. And I can work out that very easily because D has the coordinates 5, 4. So that must be 4 units high because it's 4 units above the x-axis, vertically above it. And I know that the distance between A and C, so this is C, this is A, and this is D. And we had to find, let me just make sure, we have to find the area of ACD. That's right. So we can work out what the base of this triangle is by looking at the distance between -3 and 7, which is 10. So the area, I'll just draw the diagram here, is given by this triangle, okay, which is ACD. Okay, so we know that's a right angle, but we don't care about that. We care about the vertical height, and that was 4 units. Okay, how do we know it's 4 units? Okay, because the coordinates of D are 5, 4. And we know A to C is 10 units because the distance between A to C is 7 across and then 3 more across. That's 10 units. So AC is 10 units, and that's enough for us to find the area of the triangle. The area is equal to 1/2 times the base times the height. So the area is 1/2 times 10 times 4, which gives us 20 square units. 20 square units. So there's the answer for question for part E. Okay, so there you have the answer to the question. As I said before, the easiest way to find this area of this triangle is as we did. You could have done it in other ways. For example, this is a right angle, so you could have taken these two as a base and the height, but then you'd have to find the length of AD and length of DC using the length formula, which would be complicated. So it's much easier to find the area of this triangle by using 1/2 times the base times the vertical height, and the vertical height of this is the number of units that D is above the x-axis, which is 4 units, because its coordinates are 5, 4. So this is 4 there, and the distance between -3 and 7 is 10 units. So 1/2 times 10 times 4 is 20 square units, which is the answer to that question. Thank you for watching, and if you would like to see other questions from this Solomon D paper, you can click on the icon over here. If you want to see other questions from straight line graphs, you can click on the icon over here. And if you want to subscribe to my channel, you can click on the subscription icon, which will show up somewhere in the middle. Thank you for watching, and I'll see you again soon.